what we have done is that we have talked about supervised learning. What is a supervised learning? In a supervised learning, we just have an outcome and we have a bunch of covariates. And what we are trying to do is we are trying to predict the outcome based on the covariate information that we have available with us, right? And in the machine learning literature, there is another type of algorithm that are available that does not require any outcome. So that means that you just have the covariates, right? And what is the purpose of that type of analysis then? The purpose is that just based on the covariate, I am trying to figure out which of these subjects are sort of similar, right? Say, for example, in a very simplistic scenario, you have just one covariate and that covariate is gender, male or female. There is nothing else in the data set, right? And then you do not need an algorithm to tell how these two, how this group can be splitted. You just have that gender information and you can say, oh, these are male and these are female, and you just classify them, right? What if there are more than one covariates? So you have gender, age, income, and all of this. And your objective in this scenario would be to identify subjects who are similar based on the characteristic they have, right? Does not necessarily mean that they will have to be exact matches or they have to have all the categories exactly the same. But based on all of these categories, the algorithm, this unsupervised learning algorithm, what it will try to do is it will try to separate out some participants from the others based on how close their relationship with each other, based on the covariates. Does that make sense? Okay. Okay, so the objective in this situation is low interclass similarity. That means that observation from different clusters will be dissimilar and observations from same cluster would be similar. So if you are having two groups, one group, the group members should be similar to each other, but those group members should be very different than the other groups, right? So that is the main objective we are trying to achieve here. And there is this some sort of functional form. I'm not going to go into too much detail, but I'm going to talk about one particular algorithm that is extremely popular in doing this unsupervised learning, and that is known as the k-means algorithm. And the algorithm is actually very simple if you think about it. What this algorithm is trying to do is, before doing the algorithm, you need to figure out how many groups you want to split this data set into. So, and that is the weakest point of this algorithm, is that you have to specify as an analyst that how many groups I want. Maybe I don't know. That is the answer, right? But to start with this algorithm, you have to supply like how many groups you want to determine, and that is okay. And later we will figure out how to remedy that problem. But let's just say we know that there are 3 groups in here or 2 groups in here. In that scenario, what we will do is, so for example, I'm still using the RHC analytic dataset, but I'm just using 2 particular covariates to determine which of the participants are similar to each other or not. And these 2 covariates are heart rate and education. And I just determined I want 2 groups. I do not want more than 2 groups. And what this will do, this is basically a scatter plot of the heart rate and the education. And this algorithm, when I have specified 2 groups, it will determine 2 groups based on the algorithm. How does the algorithm work? Think about, there is no color in this plot at first. What this algorithm will do, it will try to randomly pick a point and say that this is the center of that point. So for example, this is the center. And this is picking at the very beginning, even though this is not really the center. And say, for example, randomly it is picking another point saying that this is the center of the second group, right? And then it will try to incorporate all of the other members and will try to see how different, say, for example, how different this member is from this group versus this group, right? And at the beginning, it will say that, okay, this may be very close to this, so we need to assign this person to this person's group, right? And then what it will do, it will try to assess the group membership of all of the persons, and then it will try to find a mean of that first group and the mean of the second group. And it will probably find some mean in here and some mean in here, and then it will try to reiterate the process every time it calculates new mean. So every time it calculates new mean, it will again try to figure out, now that I have a new mean, how distant is the person from that new mean to the old mean, or the new person that I'm trying to assign the group membership to. And in this way, it will iterate until the point there is no more refinement anymore, right? And that is how this algorithm is defining. And this algorithm does not really have the ability to determine how many groups. Like, you have to tell them, like, I want 2 groups, and it will just figure out what are the groups. And there is another example here, and now I'm talking about 3 different covariates. I have blood pressure, heart rate, and respiratory rate, and stuff like that. And then it will try to figure out the 2 groups, and it will try to figure out 2 groups based on all of these combinations: blood pressure, heart rate and respiratory and blood pressure. And these, if you look closely, you will see these are basically mirrors of what is happening in the above, right? So like whatever is in the below, it does not have too much to offer. Whatever is in the above, or vice versa, you have to just pick one. So this is kind of a mirror of this is kind of a mirror of this, and this is kind of a mirror of this. Just the axis is different in. Okay, and see, from this you can clearly see like these red are dissimilar to this one, and this black are dissimilar to these red ones. But in here, what is happening is very strange. Like these reds and blacks are kind of like mixed together. That means what? Like the means of these 2 groups are very similar, and it is having very hard time to figure out like how the groups are, right? Okay. Okay, now let us jump into a scenario where we have more and more covariates. So for example, now we are talking about education, blood pressure, heart rate, respiratory, temperature, pH level, body weight, and the length of stay. And in that scenario, we can do all of these calculations, and we try to figure out within each cluster what are the means of these subjects that are chosen in each of these clusters. So notice that again, I have to supply how many clusters, right? So that is obviously not optimal. Like when we have like many covariates, like we have 10 covariates, and then I have to supply, this is probably not fair, right? So why not let the computer do the work for us, right? That's the purpose of machine learning, I guess. So that's what we are doing here. What we are doing now is that I'm just saying that between 1 to 10, it could be somewhere between 1 to 10. I don't know. Just figure it out. How do we figure it out? It will try to figure out the sum square, total within sum square. So this is basically this formula. Total sum square, like this is between the x and the mean centroid, we call it, and then the square term and the sum term. And what it is basically doing, it is calculating the total within sum squares for all of these number of clusters. So in here, I'm saying the computer that maybe I have just one cluster, just compute. Maybe I have 2 cluster, compute the total sum. Maybe I have 3 cluster, compute the. And the more cluster you make, the less total variation it has, right? And then how do I really determine like which is the best value? In here, things get a bit tricky. So this is previously, remember when we were choosing the best value or the not the least value, what we do is we just seek or find out what is the maximum value or what is the minimum value. I know that this is the maximum value and this is the minimum value, but like if I have too many groups, like it's probably at some point it is pointless. Some of the groups will be so entangled and mixed together, like these are not probably distinguishable. So what we do is we try to find out an elbow method. What it means that we try to find out a breaking point where the characteristics somewhat changed, right? And if you look at this graph, and you have to look very carefully and for a long time, I guess, to figure out that there might be an elbow here. That in here the pattern is somewhat similar, and in here the slope is slightly different. And if you agree with that observation, then you will say that this 3 is the optimal number of points that you need to determine. And that is how you determine how many number of groups you may want to choose for your data set.